Okay, folks, here's 2018 problem number 6. And part of what it says is that this is your slope field, and it passes through the point 0, 2, and sketch a solution curve that passes through point 1, 0. If you notice 2, 0, if you kind of follow the slopes, 0, 2, if you follow the slopes, it just looks like a straight line. And sure enough, you're just going to draw a line straight through there. That's that solution there. And then if you look at this point 1, 0, notice how the slope kind of trends like that. And then here it kind of peels back up and goes over. So, it's going to kind of go like this, down and up and over, kind of like that. So I'm doing my best here and just kind of making a quick sketch of just drawing it, something like that. So if it says draw the solution, you just kind of follow the slopes and see what happens there, okay? And yeah, it's nothing real. They'll get the idea if they give it to you, okay? Problem B says initial condition of 1, 0. And it says write an equation for line tangent at x equals 1. Well, in order to write an equation for line, you need slope and you need a point. Well, the point is, in fact, 1, 0. The slope, this thing tells you your slope. So if you plug in 1, okay, if you plug in 1, you're going to get 1/3 times 1 times, and then the y value you can see here is 0. So 0 minus 2 squared is 4, so you get 4/3. So that means that what we have is y minus 0 is equal to 4/3 times x minus 1. Now, it says use this to approximate f of 0.7. So that means if we plug 7/10 in for there, that will, we'll be able to approximate it. So y is equal to 4/3 times 7/10 minus 10/10. Or 4/3 times -3/10. Notice the 3's cancel. We get -2/5 out of that deal. Or negative 0.4. So f of 0.7 is approximately negative 0.4. Again, we're using the linear approximation. It's the idea of this. Say you have a curve, and we want to estimate that value, and we know that value. Well, if you can find a tangent line, the tangent line will give a really good approximation. Won't be exact, but it'll be really close. So we go to C, and C, sure enough, says find the particular solution to this. So we find the particular solution. That's so we have dy over dx is equal to 1/3 x times y minus 2 quantity squared. Okay. So separation of variables occurs, and in this situation, we multiply both sides by dx, so dy is equal to 1/3 x times y minus 2 squared dx. Now I need to get rid of this guy. So 1 over y minus 2 quantity squared is equal to 1/3x dx. Whoop, forgot my dy. Now that's a separation of variables. And the fact is that I know that the rest of it may seem really challenging, but so far we've got pretty easy stuff going on here. And just getting this amount can really give you some points. So when you get to here, we now need to take the integral to get rid of the dy and the dx. The antiderivative of 1/3x is going to be x squared over 6 plus a constant. And the antiderivative of that, well, let's write it out in substitution. I didn't do before, but u is equal to y minus 2. So du is equal to just dy. And so my substitution then is integral of 1 over u squared du. And the antiderivative of that is -1 over u. Okay? And so we get -1 over y minus 2. Now, the initial condition is 1, 0, it says. 1, 0. So that means if 1 goes in for x, 0 goes in for y. So -1 over -2, or 1/2, is going to be equal to x squared over 6, or 1 over 6 plus c. If you subtract the 1/6 over here, we get 3 over 6 minus 1 over 6 is equal to c, or 2/6, which is 1/3. So we got c is equal to 1/3. So we can bring that back to this part and use it to solve the equation. -1 over y minus 2 is equal to x squared over 6 plus 1/3. I'm going to go ahead and find common denominators here. -1 over y minus 2 is equal to x squared plus 2 over 6. I want to get the y minus 2 in the numerator. I have two fractions. I can simply just flip them. Y minus 2 over -1 is equal to 6 over x squared plus 2. I can go ahead and multiply by the -1, and I get, as I follow my work here, I end up with y minus 2 is equal to -6 over x squared plus 2. And finally, just add the 2 over. Y is equal to -6 over x squared plus 2 plus 2. And that's an excellent solution there. And checking my work, yep, it all looks excellent. Don't have any issues. That was 100% on that one. That was a little bit easier than the other one. So anyway, there you go. That was a short one. 6 minutes, 40 seconds.